So how do you get a good deal on a computer? It seems like everyone these days is trying to get a computer, and it's impossible. With RAM prices and CPUs and everything, it's so difficult to find something that's a good deal. Well, I'm here to tell you how to get a good deal on a computer. The three most important things to do when you're getting a new computer are first, finding a good deal, secondly, buying used hardware, and thirdly, knowing what you're doing. All of these things might sound overwhelming at first, but it's very possible to get a good deal on a PC and have something that works really well. Like this. It's very easy to get caught up in a lot of the new features that might be sold to you, like Windows 11 and things like that, and a lot of AI features, but for general use, you really don't need a lot of them. I bought a Dell 5820, which I honestly don't even know what year it's from, and it frankly doesn't matter. I have a halfway decent graphics card in it, I have a semi-modern CPU, I have a decent amount of RAM, and I don't have any problems. The main reason for that is I use Linux. Now, I can hear you saying already, Linux? Isn't that for, like, computer nerds? Just this week, there's been 2 terabytes of downloads for Brazite Linux. It's finally the year of the Linux desktop, and it's time to embrace it. So come with me and I'll show you how to get a good deal and know how to understand how to use your computer. There are 4 main parts to a computer: storage, CPU, GPU, and memory. You don't need to know what any of these mean, so long as you know what they have in terms of effects to what you do with your computer. Memory, effectively, is just how many tabs you can have open in Chrome. Your GPU is effectively what controls your ability to play video games and other intensive tasks. Your CPU is similar in terms of different types of computation. GPUs are very good at many concurrent, very easy computations, whereas CPUs are good at long recursive tasks. If I were to put this in an example, a GPU can do matrix calculations very easily. A CPU can do complex analysis very easily. Storage is what's used by your computer to store files. The more storage you have, the more photos, videos, stuff like that you can have on your computer. In terms of nuance, storage comes in 2 flavors: HDDs, hard disk drives, and SSDs, solid state drives. A hard disk drive is a lot like a record player. It's got a disk in it that's spinning at a very high speed that has data encoded in it. This data is then read by a arm picking it up. And when this arm is able to read that data, you're able to get that data back out. This is what an SSD looks like. Notice how it's much thinner and smaller. This is what an HDD looks like. Notice how it's much bulkier. An HDD works off of the principle of a spinning disk that stores the data. That means an HDD is physically slower. That also means an HDD is cheaper than an SSD nowadays. An SSD is significantly faster than an HDD, but it's significantly more expensive per gigabyte of data. Gigabytes are a measure of data. CPUs have 2 main metrics: clock speed and cores/threads. The clock speed is how fast the CPU is running, and cores are effectively how many concurrent tasks a CPU can run. You want these numbers high. in terms of storage, you don't necessarily need an SSD for storing all of your data. You don't need terabytes of SSD storage. It's just kind of a waste of money unless you're using it for important things. If you're doing video editing, I guess you should get terabytes of SSD storage. Otherwise, it's not really a problem, and it's a very expensive problem if you do. Memory looks like this. It's a way for computers to store data very quickly. To a layman, all memory is how many Chrome tabs you can have open at the same time. It's measured in gigabytes as well, typically, and you want as much of it as you can get. You don't really need to know what these are in terms of a computer, so long as you're able to find it, replace it, buy more of it, and know what you're buying. So when you buy a computer, you'll find all of these metrics, and you have to be able to determine if it's a good deal. That is the key with a computer. Anyone can build a bridge by just building it out of solid steel. Not everyone can build a bridge cheap enough for it to be public infrastructure. Anyone can build a PC for a couple $1,000s that massively overspecs anything that they needed to do. Not everyone can get a good deal on a PC if they don't know what they're doing.